The homework question chose for section 1.3.1. The one that got the most votes was problem 105, which has actually 4 different parts and brings you back to geometry. So I'm going to work through part A and B, and then C and D are somewhat similar. So in part A, it asks you, gives you a square, looks something like this, and there's a diagonal in it, and then it gives you 2 side lengths that are both equal, n and n, and then gives you a missing angle called x. In this problem, it wants you to find the missing angle, or the missing side, which we could call y, based on the information given. So one other thing about this square is there's a right angle in it, which gives you that right triangle. From this, we can conclude, because it has a 90-degree angle, we can use the Pythagorean theorem to create a relationship between the sides. So n squared plus n squared equals y squared. And we can combine like terms, n and n, to get 2n squared equals y squared. And then the last step here would be to take the square root of both sides, and the square and the square root cancel, so we're left with y equals n times the square root of 2. Which I'll go ahead and box. Alright, so that's for part A. Part B asks us to find the measure of the angle x. Now, because it is an isosceles triangle, it's got 2 sides that are equal, that means those opposite angles, opposite the sides, n, so this angle and this one must also be equal. So if they're equal, and we know that there's already 90 degrees being used for the right, we know that angle x will have to be 45 degrees. Both of those being 45 degrees, 45, 45, 90. This is a special type of triangle, which we'll use in the next section, 1.4, and this ratio of the sides, n, and n radical 2, is going to be important for us also. Part C gives us a different triangle. Go ahead and draw this in. Looks isosceles again. We'll drop down the altitude, label the sides. Gives you 2n, 2n, tells you the altitude is k, and then it also says the bottom is 2n. So this is actually an equilateral triangle, 60, 60, 60, but we're dropping an altitude down the middle of it, and we know this is a right angle. So for part C, it asks us to find the value k. We're asked to solve for k. So if we draw a separate triangle here, just take one part of this off, have something that looks like this. I'm going to cut this triangle in half. Actually, let me go back and there we go. Cut this triangle in half. Label the new sides. We still know this is k. This is 2n. And since we've taken half of the distance of 2n, we know that this will just be n. Again, we can use the Pythagorean theorem to set this up. So you'll have n squared plus k squared equals, parentheses here, 2n squared. Oops. 2n squared. N squared plus k squared equals, make sure you square both the 2 and the n, so you get 4n squared. Now the goal here is to get the k alone. So we're going to want to isolate the k. We can move the n squared over. Now we have k squared equals 3n squared. We're almost done. Take the square root of both sides like we did in the previous problem with the 45, 45, 90. And now we have k equals n times the square root of 3, because that square and square root cancel. Now we have the final answer for this. We've solved for k, our missing side. So now we have a different triangle. Part D asks us to find the angle measure of the angle labeled y, which I didn't give you at the beginning. I'll label it now. This is y. So looking at part D, it started as an equilateral, so it'd be 60, 60, 60. But since we're cutting it in half, we know this is 60, and this angle is 90, then we know that my top angle has got to be 30. So this is the second type of triangle, a 30, 60, 90 triangle. And the ratio of sides here, the shortest side, which is opposite the shortest angle, 30, is n. 60 is going to be n radical 3. And then 90 will be 2n. That's the ratio of the sides compared to the angles. If we look back at the 45, 45, 90, the ratio here is n, n, and n radical 2. And this will work for any triangle. Now, we just derived the ratios for each one. In 1.1.4, we'll end up actually using these ratios to solve for missing sides and angles.